If you've ever wondered how we maintain and update a popular Flutter package, this is how it's done for the stacked state management package. Today I'll take you through my process of adding support for forms into the stacked package. We'll start off the process as usual by creating a new feature branch and giving it a name. We'll start off by moving one of the implementations from one of our production code bases into the example app in the stacked package. We've built forms in 3 different ways, and this way I like the most. So I'm going to create a folder with the files, and then I'm going to move over the implementation that we've already used. We'll create a basic form view as well as a form view model. Then I'll move over all of the code from our production code base. So the way this was done is that we have an abstract class called base form view model, and whatever view needs to use a form has to implement this form view model class. Then I just created a new form view model which will inherit from the base form view model. Now when you inherit from this view model, you have to implement a function called setFormStatus. This function is automatically fired after you've updated your value map in the base form view model. And for the view, we were using the Flutter hooks widget so that we can get our controllers in the build function. So at the start of the build function, we'll get our controllers as well as our focus nodes. And then I add a local private function called FireFormChanged, which would be called whenever the text form value has been changed with the attached controller. Then I'll just paste in the form that we used in the actual code base, which is just 2 forms, one for email and one for password. We don't have the text form widget, so I'll remove the outline text form, and then we'll simply use a normal text form field. Then I'm just going to clean up the properties and pass in the model into the FireFormChanged function. This function will be called whenever one of the controllers is updated. And then we'll just delete all of the code that we won't require because I only want a basic form view when building this functionality. But before we work on our dream scenario, let's just log out to see if this actual form is working. So in the setFormStatus function, I'm going to log out something that will indicate to me that the form actually works when the values are updated. If we run this code now and start typing in one of the text fields, we'll see that it prints out setFormStatus with the value for email and the value for password if we type anything into the password. So just a quick overview of how this works. In the base form view model, there's a setData function which updates the form value map, calls the setFormStatus function, and then notifies the listeners. So I think I'll add some more basic functionalities just to get the hang of how this setFormStatus works. We'll start off by adding a private property called password, which will index into the form value map and use the password value key to get the value out of the map. Then over in the view, I want to show a validation message. So we'll use the property showValidation on the model, and if it's true, we will show the validation message on the model. The previous implementation of the showValidation message, we had to set it to a Boolean value. I want to change that to actually just check if the validation message is empty or not. Then we can go to the setFormStatus function, and in this function I will check if the password is empty, and if the password is empty, we want to set the validation message. So that's basically all I would need to build the form in the same way that I did for one of my client applications. And in the next step, what I usually do is I go through this implementation once it works, and I add some refactor notes around some of the things that I don't like. For instance, to get any of the values out of this map, we would have to create a key and then create this property to index into that map. And then heading over to the view, you'd have to create a controller as well as a focus node for every one of your form fields. Now when you use Flutter hooks, it's not a lot of code, but you'll still have to create it for every form field, and in one of the client apps we have about 14, so it would look quite messy in this build function. I also don't like the fact that we have to call the same function for every form field. This could be made automatic if we add a listener to the controller and we simply fire the function and call the FireFormChanged function. And then this function is also just sitting in the build method. This should be moved and we'll move it to a place where we can still automatically call it when the form data has changed. One other thing that has to grow as your form grows is the keys that we use to index into the maps. This could be generated through the stacked generator, so we don't need to create a key for every single form value that we want to track. Now that the functionality is working, what I usually do is I write pseudocode or the exact code to replicate my dream scenario in terms of how I would like the code to look for this functionality. So I'll just copy this view out and put it in my Notion document. Then I'll just go through and remove some of the things that I don't want to see in this view. The first to go is the controllers with that function like I mentioned. The second thing is that I also don't want to continuously have to call that function in the onChanged method. And then I'd like to have the clearer naming for each of the controllers, so each controller will end in the word controller. That's basically how I want this view to look. Next up, let's look at the dream scenario for the actual view model that will be implementing the form view model. The first thing is I don't want to create my own properties to access the values in that form value map. So there should be a property somewhere that I can just index into to check the value. So that's basically the only change that I want to do for this form view model. The only thing I want the developer to focus on is setting the state of the form and then calling the async function to save the data to whatever thing they want to save it to. This should take away quite a lot of code when it comes to forms and increase the speed of outputting these forms when you start a project. So this gives me quite a clear overview of what I would need to do in the package in order to provide this dream scenario in terms of the implementation for the form functionality. The first thing we can do is tell the generator what form fields to generate for us. We'll do this by creating a new annotation called form view, which takes in a list of fields which will be of type form field. This will take in a name which will be used as the name of the controller, the focus node, as well as the key for the value map. And the only other property that we'll pass in for now is the isPassword boolean. I actually don't know why we're passing that in, but we might use it later on for some additional functionality. And then what this will do is basically generate all the stuff that we don't want to have in our view or in our view model. So it should generate the keys used in the form value map, the properties to index into those values, and on the view side, it will generate all of the controllers for each of the form fields. We'll generate the focus nodes for each of the form fields. We'll also generate the function to update the form value map whenever the controller has updated. And then we need some function to call so that we can listen to the changes of that controller that will also generate through the stacked generator. So now we need to go ahead and write the generator code. Now we can go to the stacked app, and inside of the source folder in the code generation folder, I'll make a new folder called forms, and inside of that folder I'll create a new file called stacked form annotations. This is where we'll create the new form view class, and this class will have a final property called fields, which is a list of form fields. Then we'll create the form field class. And based on our example, we know that this form field should take a name as well as a boolean called isPassword. Then in the stacked annotations dot file, we can also export these annotations from the stacked form annotations file. We import the annotations from the stacked annotations file, and then we'll add the form view annotation to the top of the form view file. We'll construct two form fields, one with the name email and the other with the name password. Now we have to basically implement what we want the generated code to look like. And while figuring this out, I went down about a 20-minute rabbit hole of trying to create a new widget which we could extend from, which we can expose properties where we'll have the text editing controller and all of those things. It didn't work out because I couldn't figure out how to expose the properties to index into the value map. So what we ended up doing is creating a mixin called form view that starts with a $sign. This mixin is meant to be used on the stateless widget, and inside of it I simply just created the email and the password text editing controllers. And just to make sure it still actually works and maintains state, I wanted to just type a few things and then just minimize, delete, and see if everything works. And it seems that the controllers maintain its state properly even though it's in a mixin. Then I just went ahead and added the focus nodes as well. And I also wanted to create a function to dispose all of the controllers, since we'll be adding listeners to all of these controllers when it starts up. And then for this function, we don't want this function in the build method, so we'll have to move it into this mixin as well. We'll update the name to something more appropriate, like update form data. And then we can move over the constant keys into the mixin as well. Now, if we wanted to continue with the same route, we would still have to call the update form data function for every text form field that we have on all of the unchanged function callbacks. Instead of that, I wanted something a bit different, which we will implement using the onModelReady callback, where we can simply call a function to start listening to all the changes from the controller. Then in the mixin file, we can create the new function called listen to form updates that takes in a form view model. Now all that this function will do is add a listener to the controller. When that listener fires, we'll call the update form data function and pass in the form view model. And then we can go to the view file and remove all of the unchanged callbacks that we've added in. Now the view looks kind of close to our dream implementation, but the only difference is that we have to call the listen to form updates function from the mixin. The next thing we need to figure out is how we are going to remove these properties that index into the form value map. Since we still want that shorthand functionality, my idea is to create a set of extensions that we can use that's extended on the form view model. So at the bottom of the form view.forms.dart file, below the mixin, we'll create a new extension on the base form view model. The first thing we'll create is a getter property called password value that returns a string, and this will simply call this .form value map and pass in the password value key. We'll duplicate that and we'll change it to email value and pass in the email value key. Now in the view model, when we import the form view.forms.dart file, we can simply call password value directly and it will go to the extension because we are inside of a form view model. And that basically completed what I want the stacked package to generate for the developer when they define the form view annotation. So now it's time to actually build the generator for the stacked generator. I created a new folder called forms, and when I write a generator, I usually start by parsing the config sent from the annotation. So as you see from my services config, it's just a basic class that stores some data. I made a class called formViewConfig, and in this class we'll store a list of fields of type fieldConfig. We can then create the fieldConfig class, and since it's the exact same like the form field in the form annotation, we can simply just copy that over into the fieldConfig class and paste that in there. Then I moved on to creating the actual form generator that will generate the string to be written into our new file. I created a class called form generator that extends the base generator. I then pass in the form view config into the constructor. And since I have two generators in this code base, I just went ahead and copied the generator from the getItLocated generator. I just removed some of the code that we won't be needing, and then we can start writing our generator using the formView.forms file that we have created. The first thing we want to do is import the material package, and we'll actually handle all of the imports from this file first. One of the imports is the base form view model, which is in the example app at the moment. So I'm first going to move that over to the state management folder and create a new class called form view model. This class will extend the reactive view model in case you want to also listen to a service in this view model and rebuild the UI based on that service's changes. The list of services will be empty, and then we'll just paste in all the code from the base form view model. Then I'm going to go ahead and delete the base form view model from the example app. That way we can start relying on the one from the stacked package. To do that, I also need to export that form view model in the stacked.dart file. And then I can import the stacked package and extend from the form view model. And as you see, I got a name clash, so I had to go through and change all of the naming for form view model to example form view model. That was a quick change, so now we can continue with the imports that we want to use when we're generating our file. The second import is stacked. Next in line for the code generation is the keys that's used to assign the values in the form value map. I'm going to create a new function called generate value map keys. It'll take in a list of field configs called fields. We'll call that function after we generate the imports. I'll create a new line and then loop over all the fields and store the value in a variable called field. Then I'll just copy one of those statements and use that as the string to write in the right line. And we can simply go through and change all of the parts that we need to be adjusted to use the name of the field itself. We know that the values and the way that it's being written out is going to have to be in different cases depending on where it's being used. So we're going to use a package called recase that you can pass in a string to, and then you can access all of the recased versions of that string. We'll create a new value called case name. We'll create a new instance of recase and pass in the field name. Then for the parameter name, we'll use the Pascal case, and for the actual key value, we will use the camel case value. Now we can move on to generating the actual mixin class. This will be done in a new function called generate form mixin. We'll copy the first line that we want to generate, which is the mixin definition. And we'll do the same thing that we did for the keys earlier. We'll use that as the string for the right line, and then we'll replace the parts that will be dynamic when generating the form. So as you can see here, we'll need the form name. So I had to go back and add the view name into the form view config. And then we'll just substitute in the form name in place of the example keyword. Next up, we need to generate the text editing controller, and this entire process stays exactly the same. It's all just string manipulation. So we're going to go through, we're going to create a function called generate text editing controllers. We're going to loop through all of the fields, and for each of the dynamic parts, we'll replace that with the name from the field. Then I did the same for the focus node, loop through it, put the string in there, replace the dynamic part with a name from the field, and I basically kept doing that exact same thing. So I don't think you want me to go through all of it. It's the exact same thing over and over. Loop through the fields, put the name where you want it, write it out as a right line, and that's it. And then the only other different part that we have is when I copied the stacked locator generator and pasted that in the forms file. Then I just renamed everything to use the form generator, as well as the annotation I pass in the form view. This is the actual generator that will pass you the data from the annotation that's been added to each of the views and will allow you to use your form content generator that we just wrote, get the string to write out, and then write that as the actual file. So the first thing I wanted to get is the fields from our constant reader. I renamed that to form view since that is the form view values that's being passed in through that constant reader. We'll use the peek function to look at the fields value. The peek function will return null if it's not there, whereas the read function will throw an error if the value that you're looking for is not there. Then while I was writing this, I found out that I don't actually know how to get the view name that the annotation was on. And so I just set up the builder itself so that I can run it in the example app and see what the values is that we are getting and how I can get the view name from there. So we created a new function that returns a builder called Form Generator. It takes in the builder options like all of the other builders, and it returns a library builder which expects a generator as well as the generated extension. And for us, this will be .form. This means that the file that the annotation is on will take that exact same file name and will attach .form. At the end of it. For this builder to work, you have to define your builder definition in the build.yaml file. And I basically copied the stacked located generator and replaced all the references to stacked located generator to the exact same name as the function name of the builder in the builder.dart file. So I updated that function to be stacked form generator for consistency. And then in the build.yaml file, I simply replaced all of these values with the value from the builder file, which is stacked form generator. Then to prepare for the files to be generated, I'm going to move all of the code that we wrote that we know works into a new file called _form.example.dart. That way, when we generate the new code and it doesn't work, we have the working version to compare against to see what we are missing. And as I was experimenting, I realized that in the auto route package, which the routing functionality is based off, I remember seeing that he uses the class element to get the class name. And so I was looking for the code in the auto route package. Basically, the element being passed in is the actual class that the annotation is being used on. So to make it clearer for myself, in the stacked form generator file, I renamed the property element to class for annotation. That way we know exactly what it is when looking at this code. And to get the name of the class, we simply call display name on the class for annotation object. Then I made a function called read field config, which takes in a field config object as well as the import resolver. The import resolver I definitely just passed in because it was in the other function that we wrote. But in this function, all we do is speak for the values. We look for name and for is password. We get the boolean for is password and the string value for the name. And we return a new instance of the field config object. And when we get that value, we add it into the list of fields that we created. And the final thing to do is to construct a new form view config. We'll pass in all of the values that we extracted from the annotation. And then we'll construct a new instance of the class that we wrote where we generate the actual code. It's called stacked form content generator. This is the class that we went through where we generate the imports, the key maps, the mixin, as well as the extension functions. Now we can go ahead and test the example form view in the example app using this new generator. We'll have to make sure that we update the name of the files to be example form view and not form view anymore. When we run the build function in the build runner package, we see that we're getting somewhere, but the format of our keys were actually incorrect and I forgot to put the semicolon at the back of that statement that we generate. So to fix that up, I'm going to go over to the generator and go to the generate value map keys, and at the end of that statement just add a semicolon. Now we can run the generator again, but this time it fails with a different error, and that it says not an instance of type. But even though it failed, we did get some kind of output, so we can go and check how that looks. And the first thing that we can see is that the mixer name is in fact wrong. The second thing is that we import using .forms instead of .form, so that's something we can fix on our side. And so we can head over to the generator, go to the right line for the mixin, and just remove the phrase form view at the back of the class name that we are setting. When running build again, we can now see as it generates this output that the form view is removed at the end of it and everything compiles, which is super cool. This means that we are getting to a place where everything is working and it works exactly how I wanted it to work, besides the additional listen to form updated call that we have to do. And while I was working at a little crisis with the naming again, I didn't like that the form field class name was clashing with something in Flutter itself, and so I changed it to form text field instead, and the form text field actually inherits from an internal class called form field. And that's it, guys. I wanted to take you through this process because I have to do this every week if I want to create a tutorial on a better way to do something. I first have to implement it in a package, publish that package, add it into an app, test it out, and then I make the video. So that's why I sometimes have 1 or 2 week breaks, but I've decided from now on, if I have to do that, I am going to record it and I'll make an overview video like this so that I can give myself a new video every week for you guys to watch, as well as show you the process behind how I actually decide on what to implement in stacked packages. Yeah, so that's it. I will see you guys next week with a new boxed out episode where we'll finally build the login and the create account UI. Thank you for watching and I'll see you guys next week. Bye bye.